Alright, so your lesson for Tuesday is exponential growth and decay. All exponential functions start with the model y equals a times b, and what changes with now an exponential model is the variable is the exponent. A represents the initial amount or initial population, and b we call a multiplier. It could be called different things within different classes, but in this class we'll call it a multiplier. And B will determine two different things. If it's growth, B deals with growth or decay. So how do we determine if it's growth or decay? Well, it's growth if as x gets larger, the function grows. If x gets larger and the whole overall function declines or decays, then it's decay. Here's how you can tell. Here's an example of growth. B is going to be greater than 1. So y equals a, whatever you want as an initial population, and 1.3 to the x. Okay? 1.3 is greater than 1, therefore it's growth. For decay, you have y equals a times, say, 0.80 to the x. Whenever I would multiply a to whatever 0.8 would be after I have an initial x value, it's always going to get smaller. Think about if x equals 1, you're only going to have 80% of the population left, whereas over here you have, for your growth, you have 100% plus an actual another 30%. Other common forms of growth functions would be functions that double. For instance, say you have an initial population of 100 and that population doubles every hour. This would be a representation of a doubling function, which would be growth. B is greater than 1. What about another one that you may have seen within a science class is if you have a population that starts off with 100 but has a half-life, and it halves every day, every hour. We have to define what x is going to be. This would be a halving function, or you guys have talked about half-life. This would be considered decay. So what if I had a function that has a growth rate or a multiplier, a growth rate of 8%. So something that grows at 8%, and we'll say it has an initial population of 200. Now the function that can represent this is y equals 200 for my initial population times, b would have to have that 8%, but it is growth, so b has to be greater than 1. So it would be 1.08 to the x. 1 is to ensure that you keep the initial population that you have, and then 8% on top of that. If you did just 200 times 0.08, it would be decay. For decay, say it decays at 6%. Well, the common problem students would write is, well then, a, whatever your initial population is, and then 0.06 times x. No, this means this would be incorrect, because if you have an initial population of whatever you like, a, and you multiply it by 0.06, you only have 6% left. This is decaying by 6%. So how much do you actually have left after one cycle through? You have 94%. So to come up with b, in this case, you would take b and take 1, which is your 100%, minus 0.06, which gives you 0.94. So a function could be y equals 300 if that's what the initial population is. And again, this has to be stated, times 0.94 to the x. And that's that. This is what your entire lesson is going to be based on. In the description, I will have your assignment as well as post on Edmodo. Thanks.